Welcome back to freehighschooleducation.com. Today we are going to do Chapter 5 review on page 196. Before we go into the review, I just want to explain a situation that we encounter in solving inequalities with the absolute value. Let's say we have an equation, which is this one, and we are going to solve this one. So we expand the parentheses and here. Next we bring the 15 to this side and take the 4x to the other side and change the signs. Here we get 16 minus 15 equals to x, and finally we get 1 equals to x. As we are solving these exercises, we are generating equations, and these equations are a little bit different from the original one because the quantities on both sides of the equation are different than the original quantities. We are moving quantities from one side to the other, or removing the same quantity from both sides. So we are generating different situations, but the two quantities are always equal. So here, this x equals to 1 is a solution to everything that we have done before. And this also applies to what we are going to do with the inequalities that have absolute value, because some students get confused when we solve these inequalities. So let's take an example. And we are going to practically do the same example that we have done initially. And that's 8 minus 2x minus 4 is less than minus 4. We take the 8 to the other side. Is less than minus 12. And now we divide by minus 2. And we get 2x minus 4 more than 6. Here, if you are going to use the quick way, and we said in that case we equate the absolute to 6 and then solve. We solved this in the introduction to this chapter in the first session, and at that time we got 2x equals to 10 and x equals to 5, and this was one of the roots. And if you equate this to minus 6, you get x equals to minus 1. So at one point we got 5, and one of the roots 5 and the other root is minus 1, and we solve this. And here is the tricky part. We are solving at this point this inequality where we have a positive absolute more than 6. But when we solve this, we are also solving this inequality and this inequality. So when we are going to look at the position of the answer, is it between the roots or outside the roots, you are going to decide based on this inequality. In this case, it is more than 6, and that makes it outside the roots. And so our solution will be x more than 5 or x less than minus 1. Now, some students, instead of making their decision based on this inequality, they might make it based on this, and they will be looking at this sign. If you look at this sign, you are going to get the wrong answer, because then your answer will be in this region. Inequalities can be a little bit tricky, and that's why it is always advisable to get values from the acceptable regions that you got and from the rejected region, and check your work. So now we go to the chapter review and do some of the exercises. we will start with number 8, and that's minus 3z more than 18. We divide by minus 3, and we have to change the sign, so that will be z less than minus 6. Next is number 10, x plus 7 less than x minus 1. Here we have the same quantity x on both sides. If we remove this x, and minus x from both sides, we get 7 less than minus 1, which is impossible. So basically what this statement is saying is that if you have a quantity, you add 7 to it, it will be less than the same quantity after taking 1 from it, which is impossible. So here the solution is x equals null set. Next is number 20, minus 5 less than minus 1. This actually is a final solution because you can plot it right away. A mistake made sometimes by some students is to do this following. Mix up the number line. So you put minus 5 here and minus 1 here. This is the wrong position of the numbers. So you have to be careful when you graph your inequality. And here x is between these two, so it will be graphed this way. Next is number 24. Absolute x minus 2 equals to 3. Here our number itself is x minus 2, that can be equal to 3, or x minus 2 equals to minus 3. In this case x will equal to 5, take the 2 to the other side, and in this case x equals to minus 1. Next is number 26, absolute c plus 3 equals to minus 1. Here the absolute is always positive and it cannot be equal to a negative number, so this is an impossible situation, and the answer is c equals null set. Next is number 29, minus 2, absolute for x minus 2, minus 8 equals to 16. First thing is to isolate our absolute. We take the 8 to the other side, add it to the 16, and that's equal to 24. Now we divide everything by minus 2, and we get here absolute for x minus 2 equals to minus 12. This is an impossible situation as the previous one, so the answer is x equals a null set. Next is number 30, absolute x minus 4 less than 2. We're going to do it the fast way, so we are going to equate our number to 2 and generate two equations. First situation is when our number equals a positive 2, and the second situation when our number equals a negative 2. Now we are trying to get the roots. Here x equals to 6, take 4 to the other side. Here x equals to 4 minus 2, and x equals to 2. So these are the roots, and since our inequality is less than, so the solution will be between the roots. Both are positive, so we can put our 0 here. 2, 6, these are not included in the solution, and so our solution is this, and we can write our solution in an algebraic form as such: 2 less than x less than 6. Next, number 32, 5 plus 2x. Absolute, more than 9. Here again, we generate two equations, one with a positive 9 and one with a negative 9. So 5 plus 2x equals to 9, and the other one will be 5 plus 2x equals minus 9. In the first situation, we have 2x equals to 4, take 5 to the other side and minus it, and x equals to 2. Dividing everything by 2. Here we have 2x equals to minus 9 minus 5, and 2x equals to minus 14, and x equals to minus 7. And as you can see, here we have more than, so our solution will be outside the roots. And this is how we graph it. We will have 0 and minus 7 and 2. So it will be outside the roots this way. And the roots are not included, the 2 and minus 7. And the solution will be written as such: x less than minus 7 or x more than 2. Remember that when we have more than, this is a disjunction. Next is number 34, absolute minus 2y plus 1 is less than minus 1. This is an impossible situation. This is a positive number. It cannot be less than a negative number, so y equals a non-set. Next is number 35, 9 minus 3, absolute x minus 2, less than 6. Here, we take the 9 to the other side, so we have minus 3, absolute x minus 2, less than 6, minus 9, minus 3, less than minus 3, we divide by minus 3, and don't forget to change the sign. So we get absolute x minus 2 is more than 1. Now we are going to solve this and get the roots. In the first instance, this would be x minus 2 equals to 1, or x minus 2 equals to minus 1. In this case, x equals to 3, and in this case, x equals to 2 minus 1, and x equals to 1. So our roots are 3 and 1. And we are solving now this inequality, and the sign is more than, so the answer will be outside the roots. You can see that this inequality is completely different than this inequality in the way it looks, but they are the same, in the sense that the solution for this will be the solution for this. 3. Our solution is outside the roots, so it will be smaller than the smaller, larger than the larger. And the solution is written as such: x less than 1, or this is a disjunction, x more than 3, since we are solving this inequality. So the answer to this inequality is the answer to this inequality, and you can try values in this region, here and here, and they should give you a true statement. And if you try a value in this region, it should give you a false statement. And with this, we come to the end of this session. We hope to see you again.